Hi everyone, we're going to evaluate the given integral and we're going to use u substitution. So what I'm going to do for this one is let u equal x squared. Therefore du equals 2x dx. And because we have an x dx here, I'm going to write x dx equals 1/2 du. Alright, so let's substitute that in. You substitute that in, you're going to get, this is going to be square root of 1 minus, now u is x squared, and we have a 4. So instead of u, you're going to write u squared, because u squared would equal x to the 4th. Now x dx is just going to be 1/2 du. All right, furthermore, I'm going to make a second substitution, and I'm going to let u equal sine of theta. Therefore, du equals cosine of theta d theta. I also know that cosine of theta is going to be the square root of 1 minus u squared, because we know that cosine of theta equals the square root of 1 minus sine squared theta, because this just equals cosine squared, and you take the square root of that, you get back to cosine. All right, so remember, we're letting u equal sine, so I'm just writing everything we need here. So since we have that, I can rewrite this integral as I'm going to pull this 1/2 out front of my integral, and then I'm going to write this, it's just going to be cosine theta, and then du is just going to be cosine theta d theta. So that's going to be times cosine theta d theta. Now, what I want to do is, since I have this is cosine squared of theta, and anytime you have that, you want to use your half angles because they're easier to integrate. So I'm going to rewrite that as 1/2 integral of 1/2 times 1 plus cosine 2 theta. So that's your half angle integral for, or your half angle identity for cosine squared d theta. Now that we have that, we can integrate this. So we're going to get, let's write this as 1/2 times 1/2 of theta plus 1/2 sine 2 theta, and then you have your plus c. All right, now let's clean this up a bit. So I'm going to write it again. We had, if I simplify it further, we're going to have 1/4 theta plus 1/8, and I just distributed that out, sine of 2 theta plus c. We have to move this back to x, so what I want to do here is use my double angle identity and write this as 1/4 theta plus 1, this will be 1/4 times 2, this is 1/8 again, times 2 sine theta cosine theta plus c. Well, this is going to end up being 1/4. All right, so just remember this, let's just erase and write this as 1/4. So this is going to be 1/4 here. Now I'm going to draw, well, let's just we use substitution. So we know that we have 1/4, and our u equals sine of theta. So theta equals sine inverse of u. So I'm going to write that sine inverse or inverse sine of u. So I'm just rewriting the u parts right now. Plus 1/4. And this part right here is just going to be 1 minus u squared plus c. Now, we got to go back to the x, so we're going to change all our u's back to x's that we did. Remember, we let x equal x squared was our u. So let's plug that back in so you can get 1/4 inverse sine of x squared plus 1/4 x squared times the square root of 1 minus x to the 4th plus c, because that was your sign there. All right, and that's it. Thank you. Have a nice day. Bye-bye.